So recall at the end of chapter 5, I mentioned a couple limitations. One of those being this whole idea of our third variable problem of confounders. That we can't necessarily say that A causes B because there may be something else that's going on there. Right? If we're talking about somebody drinking alcohol and smoking and those relationships, well, there may be some other things that may contribute to somebody's first age of smoking or first age of drinking alcohol, such as do the parents drink? Do the parents smoke? Do these kids have access to money where they can buy these things? Do they have access to somebody who's of legal age to buy these things, right? All of these other factors, all these other variables that you may measure or not measure that can have an effect on your outcome, on your DV. And so it's just something you have to think about whenever you are running a correlation coefficient. It's thinking about even if you find significant or not significant relationships, think about what are some other confounding variables that may have led to such findings. And because of that, we cannot say that the IV causes the DV, nor does the DV cause the IV, that variable X causes Y or Y causes X. Because we don't really know which one came first, what causes what. We just know that there is a relationship between those two, thus the variances that they share. And then the last limitation that I want to cover, which we didn't talk about in chapter 5, is the idea of sample size and the ease of finding significance. So if we have a larger sample size, it's more sensitive to finding significance, which means it's easier for us to reject the null hypothesis. But if we have a smaller sample size, it's going to be harder for us to find significance, which means we're going to have a bigger critical value that we're going to have to overcome. So let's take a look at these two correlation matrices to help illustrate this limitation. Both of these tables have the exact same variables, alcohol and all of the other substances. The only difference are the sample sizes for each one. The second table, the bottom here, has about 10 times more the sample size. So if we're looking at alcohol and cigarettes, well, we see that the correlation coefficient relatively stays the same in terms of strength and direction. 0.452 when we have 257 people compared to 0.451 when we have 2,564 people. But take a look at the p-value. Look at that significance. Didn't change much. But take a look at these three variables: ecstasy and alcohol, pain relievers and alcohol, and OxyContin and alcohol. Looking at alcohol and ecstasy, we see that in the first table we only had 38 people, and we had a pretty weak to no relationship. That was not significant. But if we had 10 times the people in our sample, where we have now 375 individuals, well, now we find a weak relationship that is significant. So when we just had 38 people, there was a no to very weak relationship that was not significant. But when we had 375 people, we had a significantly direct weak relationship. Same thing with OxyContin. When we only had 21 people, we had no significant relationships between OxyContin and alcohol, and that pretty much gave us a no to very weak relationship, which wasn't significant anyway. But when we have 186 people compared to the 21, well, now we see a very significant relationship. And that relationship is actually pretty weak, almost to a moderate relationship. So notice that the more people we have, the easier it is for us to find significance, to find significant relationships. All right, so to summarize chapter 15, remember, correlation coefficients are used to examine the relationship, the correlation, the association, the connection between two interval ratio variables. And these interval ratio variables need to be ungrouped. But if you have two variables that are both ordinal, then you need to run a Spearman's correlation coefficient in SPSS. Remember that our correlation coefficients are a function of two variables, x and y, and that our r can range from -1 to +1, and we talk about the direction and the strength. And so we always report in our conclusions the mean and standard deviation for each variable, your test statistic, your degrees of freedom, and your p-value if you know it, if not, your significance level. And then if it is significant, then you further report the strength and the direction of that relationship, and then calculate, report, and interpret your coefficient of determination.